Good morning, all the dignitaries in DAS and respected delegates to the August gathering to the Indian Construction Weeks 2020. I am Dr. B.N Mohapatra, Director General of National Council for Cement and Building Materials. It is honored to speak in the inaugural address in this seminar. Our most topic is NCCBM's roles towards sustainability of cement and construction sectors. National Council for Cement and Building Materials is the R&D organizations under the Ministry of Commerce and Industry, and we are solely devoted to the technology transfers, innovations, teaching to the industries and our building material sectors. Sustainability is the buzzword, and it is connected to sub themes like climate change, circular economy, Swachh Bharat mission, 5C approach, zero waste emissions, alternate fuel and raw materials, and Bureau of Energy Efficiency PAD scheme, research conservation, sustainable development goals, and carbon negative concept. So if you can go to 5C approach, you see it, in the cement industry, we are producing clinker, then cement, then ultimately building materials are taking it, making the cement as a raw material, then making concrete, and ultimately constructions and the carbonations. This is the 5C approach. Clinkers, we will make our target is that with the less consumption of the limestone and also fuel. That's why our alternate raw materials, alternate fuels also can be utilized as a replacement of as a part replacement of the clinker. Similarly, cement, we are utilizing cement with the less consumption of the clinker to reduce carbon dioxide emissions, and we are making about blended cement and utilizing fly ash and slab as the largely industrial available materials. Then cement contribution of the clinker will be minimum. Similarly, with concrete, we have to make the concrete with the less consumption cement, and we have to use the admixture to optimize the mixed constituents. And constructions, similarly carbonations, also it will be reusable. Carbonations, carbon dioxide emissions, actually the source that can be stored from the calcination of the limestone to make the clinker, and again that carbon dioxide stored can be again utilized for the carbonation properties of the concretes. In NCCBMs, depending upon the presence, requirement of the industries and building materials, we have made 22 expertise teams like mineralogy and microstructures, new clinker systems, low carbon cement, high temperature technologies, XRD and SRM, advanced analytical techniques, alternate fuel and raw materials, advanced comminution and particle technology, and civil advanced pyroprocessing. So that is, you can see this is the completely related to the civil industries. And energy conservation, renewable energy, carbon capture and utilizations, power system instrumentation. This again, these are the expertise team which are supporting to the cement industries. Structural design and systemic evaluation, geopolymer concrete, repair materials and rehabilitations, advanced concrete composites, reinforcements, corrosion prevention and mitigations, concrete durability and microstructures. That these are the groups who are working for the durability of the new latest design concretes. So BND and SRMs, you may be knowing that you have the Nirdesha Dravyas and standard reference material that also being developed by the NCCBM, and we have replaced our 12 standard sample BND, and also that is helping in the import substitution. And as because Atmanirbhar India, this is the main important project we are also conducting with the supporting of the National Physical Laboratory. Laboratory accreditation management, NCCBM also supports for the enable accreditation of the laboratory on its own premises, at the same time Indian cement industry, cement sector also. The last group, the institutional linkage and networking. In NCCBM, we are connecting to the different universities and also IITs, NITs, actually to work together, and also our expertise can be utilized by them, and also their expertise can be also expertise by NCCBM, and also we will also do the research work and also paper publications and making the seminars which will integrate in our India. Carbon dioxide emission from Indian cement industry, you can see that cement industry is also considered as the highest polluters. But now you see that it contributes 7% of the anthropogenic carbon dioxide emission. The total carbon dioxide emission from the Indian cement industry is 200 million tons per annum. But the target of the reduction of carbon dioxide emission in 2096 is 1.12 tons of carbon dioxide per ton of cement, and it is reduced to 0.670 to carbon dioxide emission per ton of cement in 2017. So the target is still there. We have to reduce the carbon dioxide emission per ton of the cement to 0.35 tons by 2050, as estimated in the technology technology roadmap. So for that, actually, steps taken by the cement industry for the reduction of carbon dioxide footprint, there is 5 levers. One is substitution of clinker, alternate fuel and raw materials, waste heat recovery, improving energy efficiency, newer technologies like carbon capture and storage, and utilization of renewable energies. These are the 5 levers we are working together for the reduction of carbon dioxide emission. So you see the graph, you see that your clinker substitution has the greatest potential for the reduction of carbon dioxide emissions, and after that, carbon sequestrations. Now you see the blended cement distributions in India. OPC in the 895, you will see the figures, that is 70%, 19% PPC, and also 11% is other Portland slag cement. You see with the advancement and the years 2017, you see the figure that 70% OPC has become to 27% OPC, and 19% PPC has become 65% PPC, and 11% PSC has become 7% PSC. And here in this figure you show that 65 plus 7, 72% total blended cement produced out of 100 in India. And step undertaken for the NCCBM low carbon cement, because beside this cement, NCCBM is doing the research continuously on the development of new type of cement. So also to reduction of carbon dioxide emission. For that, you see the Portland limestone cement, where the limestone can be utilized from 15 to 35%, and also different grades of limestone. Portland dolomite cement. Dolomite is not utilized in the cement manufacturing, but here we can see it. Dolomite also can be utilized as a clinker replacement and making Portland dolomite cement. And Portland composite cement based on fly ash and limestone, or composite cement based on fly ash slag. Composite cement already come to the market, and as because slag is not available everywhere, so NCCBM has thought that so another ternary composite cement can be developed by the utilization of fly ash and limestone. And limestone is plentifully available everywhere, so fly ash is also plentifully available. Out of 200 million ton of the fly ash generation from the country, 26% utilized cement industry, and still 26% even unutilized. So limestone and fly ash is plentifully available. So we think that by utilizing this fly ash and limestone, there is a potential for the reduction of carbon dioxide emission. Then develop low carbon clinker, belite calcium sulfur clinker and cement. This is a new type of clinker NCCBM developed, because since last 50 years we are producing high thickness clinker, as a result of which we are utilizing high grade limestones, and our thermal energy also like 1450 degrees centigrade, and carbon dioxide emission is also reduced. So now by developing this low carbon clinker, there is a potential to reduce carbon dioxide emission by 30%, and also thermal energy can be reduced by 200 degrees centigrade. And geopolymeric cement, fly ash and slag, only by alkali activations or using the polymers, this cement can be developed. A limestone calcite clay cement, this clay is abundantly available in India, different type of clay, and our IIT is also doing develop the product of limestone calcite clay cement. And now we are taking the project completely. Clay available in India, different type of clays, and how to make it calcite and make it in the cement. Similarly, multi-component blended cement, it can be also utilized. 4-component system, slag, fly ash, limestone, clinker together can be utilized. And in this respect also, we are also doing the work. A new clinker, which we have already discussed, that is having about 52% beta-sweetness, malite, and a new phase has developed 22% ilmenite, that is calcium sulfur aluminate. And with this clinker has seen that it is giving the high compressive strength in 1 day, and rate of development going to be lower, but at the same time we are getting about 48 MPa strength in 28 days. This clinker has been developed by utilizing the low grade limestones and industrial waste, and we have seen that the firing temperature has reduced by 200 degrees centigrade 1250 degrees centigrade, this clinker is completely formed. A low-grade limestone can be utilized up to 15%, and industrial byproducts can be utilized as a source of the iron and sulfur. Jarosite, red mud, wollastonite, these are the natural the byproducts of different industry can be utilized, and by that carbon dioxide reduction will be 20 to 30% as compared to the conventional clinker. Then alternate fuel uses in Indian cement industry. This is also taken the move from 2005. An alternate fuel means any material having calorific value like plastic waste, polythene, agricultural waste, carbon black, tire chips. Those who are having the heat value, that can also be replaced as a fuel in the cement industry. And in cement industry, it also utilizes as a source of the fuel. You can see it from the graph: 75%. 73% solid waste, carbon black, tire waste, RDF plastic. This is the percentage we can utilize, and also liquid waste for pharmaceutical waste having hazardous and also calorific can be utilized. You can see the inventory of the Indian cement industry. These are the type of the different wastes have been inventorized. About 75 types of the material have been utilized, can be utilized in the alternate fuel. Similarly, alternate raw materials. Now we are using the limestone, clay, and moram as the alternate raw materials of cement. But at the same time, industrial waste like fly ash, steel slag, other things having alumina, silica, iron, that can also be utilized in the alternate raw materials. So our first is there, how to identify the different type of raw materials also can be utilized as the alternate raw material in cement industry. The third lever, you can see energy efficiency. Here you can see that how to recover the energy, electrical energy, and also the wind energy, renewable energy, wind and solar. So here by this you can see that waste heat recovery system already implemented in so many industries. At the same time, we are exploring the renewable energy installed capacity like wind and solar. So by this actually we can reduce, and the plant's PAD cycle can surpasses the energy saving targets and achieve the saving of 1.48 MTOE, which is around 81% higher than the saving target. Then about energy efficiency, you can see NCCBM has the expertise in the energy efficiency group. NCCBM is the accredited energy auditor, and 7 certified energy auditors are already there. NCCBM has been actively involved in development of normalization factors on the PAD scheme, and NCCBM has carried out over 100 energy audits of cement plants. NCCBM has also undertaken techno-economic feasibility study for setting up the waste heat recovery system at cement plants, and energy monitoring and motivation of improvement. National awards for energy efficiency in Indian cement industry are also done by NCCBM. So the last attempt is carbon capture and utilization. This is the latest technology, and we are very infantile at this stage. However, we are also coordinating with the experts, and these are the different technologies already developed: Solidia, Salite, Cement, Eco Binder, Ether Low Carbon, Carbon Capture, Carbon Cure, Carbon Aggregates, and all these are carbon. These are all development under the scheme. So that is also carbon sequestration and carbon storage. And the studies undertaken for the resource optimization, you can see NCB has already done the work for the high magnesia clinker, where the 8% clinker can be successfully utilized for the production of PPC and PSC, so that NGO having certain limits can be utilized in the production of the clinker. So it will also save about 15 years life of the limestone reserves. Similarly, slag, synthetic slag, and other coarse fly ash, 200 to 250 meters per kg, not utilized now in the cement industry. That also we are taking the projects how to utilize this coarse fly ash. Development of fly ash with geopolymer concrete also, less cementless concrete. Ferrochrome slag as a fine aggregate, and a coarse aggregate in concrete. Study the preparation specification guideline for use of coal-based bottom mass as a replacement of fine aggregate, and study the use of CND waste in low volume concrete roads. This work has been undertaken in our CDI department. So thank you for your kind attention.